Hello to all the first LEGO League teams participating in the Virtual Open Invitational 2021 Challenge. I am Dimi and I teach Industrial Automation at the Vives University College in Belgium. We teach our students to program industrial robots, but for the basics we start with LEGO robots. I have been asked to tell you a bit more about one of my robots design. This is my Spike Prime balancing robot. It's actually a very simple robot that's quick to build. I made building instructions with the Studio software, and you can use that software also to make nice animations like this one. As you can see, this robot consists mainly of a spike hub, two motors that drive the two wheels, and it has a distance sensor. That distance sensor are mainly used to give it eyes. It's not programmed to do anything else. But the most important sensor is in the hub itself, the gyro sensor. With this sensor we can see if the robot is standing upright, but we can also see if it's falling forward or backwards. If it's falling forward, we can program the robot to go a bit faster, to drive forward faster, so it becomes upward again. If it falls backwards, we program the robot to drive backwards. Let's have a look at the code. So this is the program of a robot. It looks like a lot, but actually the most important part is here in this forever loop where the magic or the math is done. When we look at the start of the program, we put everything to 0 first, and then very important, we set the pitch target. What is the pitch target? That's what you can see here. When I balance the robot, I can see the pitch angle is measured always, and I can see when I try to balance him manually that the pitch angle where his tipping point is around 44 degrees. So that's what I have filled in here at the pitch target, 43.7 I have put in, and that is the wanted value of our PID controller that will look for balancing this robot. So these values I will fill in later. But next we tell the robot that it's motor A and B that is connected, and we tell him to get up. So this is the get up sequence. It's not really important, it just makes the robot turn 360 on the ground, then he drives backward, makes 3 beeps, goes forward, and when he brakes the robot will tip over, and when the pitch angle is between these values he will go upwards and start the PID controller that keeps him balancing. So when he's got up, we will reset the timer, turn on the eyes, and set the integral value to 0. And here is the PID controller. So the most important one is the error. That is the difference between our wanted angle of the pitch and the current angle. So the bigger this error is, the more the robot needs to correct himself and has to put more power in the wheels to get back to his upright position. The integral uses a timer and the error to determine the history of the error, so that if the error takes on a long time, we can put extra power in the motor to correct the error. And the last part is the derivative. This calculates the difference between the previous error, so it determines how much the error is changing, and in that way we can predict what the error will do, and we can use that also to control our robot. So those 3 parts, the current error, the history of the error, and the predicted future of the error, can be used with a constant multiplied by a constant, and will be used to calculate the power that we send to the wheels. So I have determined that those values are the best to keep him upright, and when we start this program, our robot will start balancing. We can use this for all kind of purposes. It's always fun to see him balancing, but we can let him do a sumo fight if we change this pitch target a little bit forward, so he starts moving forward a bit, then we can have a sumo fight. Or we can multiply this value by a remote control, so we can drive it, the robot, as well. Let's see that in action. I am looking forward to seeing your robots at work at the VOE challenge. Good luck!